Hi there, everyone. Welcome. I'm Andrew Fazekas, the Night Sky Guy, your host for Friday Find, where I love to share what comes across my desk every week as an astronomy journalist. Always interesting stories and some that pique my personal interest. And I thought I'd share things that I find cool with you guys. And today is November 11th, 2022. I hope you had a great week. And it's great to see folks from around the world turning in. I've got friends from Turkey, from India, and Michigan in the United States. Fantastic stuff. Why don't we start off right off the bat with some news to share? Let me share. The first one that came across my desk that I thought was interesting, right actually today, is update about the Artemis mission. And you might have heard of the Hurricane Nicole in Florida. Perhaps giving worries about the Artemis mission, the NASA's return to the moon mission that's been put off multiple times over the last couple of months because of weather delays, technical delays. And so NASA is now investigating very minor damage from the hurricane. This is from Space News, fantastic website, an article by Jeff Faust, dated today, November 11th. You can see a great picture here of the Space Launch System, this mega rocket that's supposed to return us to the moon. And NASA is saying that the initial inspections of the rocket on the launch pad, including the Orion spacecraft, have turned up, quote, very minor damage, but they didn't add any more to it, it seems. Yesterday, November 10th, there was a tweet by NASA's associate administrator that basically says using launchpad cameras that are set up on the launchpad system, they didn't show any really cause for concern, major damage, but we'll see. What did they say here? Loose caulking and tears in weather covering. So we'll have to see how that goes. But right now, it says NASA said November 8th they would not attempt a launch on November 14th. So that would have been, I guess, 12, 13, 14. That would have been on Monday that they originally planned. But now instead they're targeting November 16th with November 19th as a backup date. So let's hope that this actually launches. I'm going to send this very good article. You guys can read it on your own. I'll put it in the comments so you can investigate that yourself. But I think that's really important to see. Here we are again. This I don't know. It's such bad luck for Artemis. Hopefully, it will do better. Now, what else caught my eye is a really interesting release from the Hubble Space Telescope. Always love the images that come back from the Hubble because it's really. It's over 30 years old, but it's still pushing the boundaries of what our knowledge is of the universe. And here it is. It's captured 3 phases of evolving supernova in early universe. So what are we talking about? So we're talking about a supernova, a giant star that has exploded literally at the edge of the universe. We're talking over 11 billion light years away. This star inside of a distant galaxy, right? Remember, galaxies are basically giant islands of stars, millions or billions of stars all huddled together. We live in one called the Milky Way. And this particular one exploded back in the early days of the universe. And it says this happened when the universe was less than a fifth of its current age, which we estimate at 13.8 billion years old. This is the first detailed look at a supernova at such an early time in the universe's evolution. The data could help scientists learn more about the formation of stars and galaxies in the early universe. Now, what's really interesting is how were they able to see a star explode so far away, 11 billion years back in the past? Well, it's all thanks to a phenomenon called gravitational lensing. It was first predicted by Einstein's general theory of relativity, basically. And in this case, the light took 3 different paths through basically a lens, a cosmic lens of a massive galaxy cluster called Abell 370 that bent and magnified the light from the more distant supernova that was in the background behind that giant cluster of galaxies. So this galaxy sits between, think of this galaxy cluster sitting between us and this very distant supernova. And that light from that ancient fossilized light from that supernova traveled through space for billions of years and then encountered this giant cluster of galaxies, this very massive cluster, and the light got bent by the gravitational well of this cluster of galaxies and continued on its journey to us. But it bent it into 3 different beams of light. And so you can see in this image right here, 1, 2, 3, these collection of images here. This is where the cluster of galaxies is, this Abell 370, and there's the light from this ancient galaxy in the background, and there you can see 1, 2, 3 different images of the same supernova. Really, really interesting stuff. And that's without the annotations. And you can see multiple light. Here is here's the Hubble Space Telescope. Let me just pull that up a little bit here. Hold on. There you go. You can see it now. And so what's happening is that you've got this ancient galaxy, supernova explodes, travels through space for billions of years, right? And then it encounters this giant galaxy cluster, and the light is bent into 3 different patterns, and it's collected by the Hubble Space Telescope. Really, really interesting stuff. And there's a really good little explainer video here about what gravitational lensing is all about. Let's just check this out, and I'll explain it better than I could in terms of what gravitational lensing, because these images are great.
Light does not always travel in straight lines. Einstein predicted in his general theory of relativity that massive objects will deform the fabric of space itself. When light passes by a really massive object, such as a cluster of galaxies, its path is bent slightly. This effect, called gravitational lensing, is only visible in rare cases, and only the best telescopes, including the NASA ESA Hubble Space Telescope, can observe the results of gravitational lensing. The strong gravity of a massive object, such as a cluster of galaxies, warps the surrounding space, and light from distant objects traveling through that warped space is curved away from its straight-line path. When light from a distant galaxy is bent around a cluster of galaxies between it and us, we see multiple images of the galaxy, each with a characteristically distorted shape. These shapes can appear as lines, banana-shaped arcs, and even rings. Hubble's sensitivity and high resolution allow it to see details in these faint, distorted images of distant galaxies that cannot be detected with such clarity by ground-based telescopes, whose images are blurred by the Earth's atmosphere. An important consequence of gravitational lensing is that the distorted image of the distant galaxy is actually magnified, allowing us to observe details of the objects that would otherwise be too faint to be seen. Hubble makes use of this magnification effect to study objects that ought to be beyond the sensitivity of its 2.4-meter diameter primary mirror.
Okay, just very quickly, look at inside this image right here. You can see all those arcs. See these weird squiggly lines all across this image, little blue squiggly lines? All of those, and they're like this big one over here, they're all bent by gravitational lensing, this effect. It's really amazing to see how distorted some of these background galaxies actually do become because of gravitational lensing.
Showing us the most distant galaxies humanity has ever encountered. Depending on the total mass of the intervening cluster, gravitational lensing can be used to weigh clusters. This has considerably improved our understanding of the hidden dark matter in galaxy clusters, and hence the universe as a whole. If the galaxy cluster contained only the matter that we can see directly, its gravity would not be sufficient to distort the light in the way that we observe it. So there must be additional invisible matter present, and gravitational lensing tells us how this so-called dark matter is distributed within the cluster. The Hubble Frontier Fields Observing Campaign drew on the influence of massive clusters of galaxies to unleash the full potential of the Hubble Space Telescope. The program used 630 hours of Hubble observing time over 560 orbits of the Earth from 2013 to 2017.
So really interesting stuff. I think this just shows that the power of Hubble Space Telescope, despite it being, older, obviously, over 3 decades old, it's still doing amazing stuff. And I think this one, the fact that it's able to see supernova so far away, these exploding stars, it really helps us understand what the young universe, the baby universe really looked like and how it evolved to what we see today. The Earth, our sun, our home galaxy, all of that, how it evolved. So let me share with you this particular press release. It's really interesting. You can read it and look at all the images. It's very, very cool. Let me just pop that in there in the comments so you can have some reading for yourself. And finally, I mean, we got to talk about also the lunar eclipse, right? I mean, the lunar eclipse was huge. Let me see. This is one of my favorite websites, spaceweather.com. And on spaceweather.com, this is their image gallery, some beautiful images of the lunar eclipse. Here's someone from Australia, Marco Nero, showing his image of the moon. And I've done a few of those myself. Let me see if I have my albums. I'm just going to see here, show you some of my pictures that I've taken of the lunar eclipse. This one was a really neat one I took. It's all through iPhone. I use my iPhone 12 Pro Max, put it on a tripod. It unleashes more than the usual 3 to 10 second exposures. You can go up to 30 seconds. And in this case, you can see the moon right there. It's just heading into total eclipse. There's a nice lake with reflection, the orange reflection of the orange moon. Of course, that is because of all the sunrises and sunsets around the world being projected onto the moon. Really cool. You even see the Pleiades star cluster right there, and you can see the head of the bull, Taurus the bull, the Hyades cluster that it represents there. And there is right at the top there, I think you can just barely see the, whoops, let me see if I can get that. You can see the Aldebaran, the red eye of the bull. That's right there. So this is really, really cool. I was able to do that. I was impressed how the camera actually functioned. I did get some other ones, like this one was a nice one too. I thought captured. This was over a lake where I live. It was about -4 degrees Celsius. It was fantastic. But the sky and the moon in the sky, I should say, moves around quite a bit quickly. And by yesterday evening, I took a picture of the moon next to Mars right there. Again, with the phone, the moon is just kind of totally, blaring through the phone. There's an actual contrail from a jet that happened to fly by, but that little dot there is Mars. And this dot over here is the star at the tip of one of the horns of Taurus the bull, called Elnath. It's a 130 light year distant star, and it was really easily visible. And this is what it looked like in this, on the planetarium program. There's Elnath, there's Mars, and there was the moon. So this was Thursday night, but here we are Friday night, and you get a redo. but this time the moon is going to be on the other side. So you'll have Elnath, Mars, and the moon again making a really neat triangular formation. I'm going to have a sky chart put on my social media pages. So whether you're watching on Twitter, YouTube, I'll also put it on Instagram, probably Facebook as well. And you guys can try this again. And if you have a phone, try to take a picture and share it with me. I'd love to see that. So there you go. Something cool for this Friday night. Try that out. The moon, Mars, and Elnath all together. A planet, a moon, and a beautiful star of the constellation Taurus, the bull. Isn't that cool? So thank you so much for joining me. If you like these videos, please give it a thumbs up and don't forget to hit that subscribe button. It means a lot in terms of support, whether you're watching on YouTube or Facebook or Twitter. Thanks so much. And of course, before I leave, don't forget, I've also got my new book out, Stargazer's Atlas, The Ultimate Guide to the Night Sky. It covers both the northern and southern hemisphere equally. It's got tips and tricks of observing, tours of the night sky that you can do with binoculars and telescopes. And it has a lot of science background about the objects in the sky and astrotourism, archaeoastronomy, where you can go travel around the world that has astronomically themed destinations. It's got the entire humanities connection to the night sky above. It's all published here in this beautiful book out by National Geographic. I'm so excited and so proud to be working with a wonderful team of writers, illustrators, cartographers at National Geographic. And it's really 6.5 pounds of cosmic knowledge. It's available on my website, thenightskyguide.com. I'll put a link below if you want a signed, dedicated copy. Then drop on by. I ship internationally for that. So that's it for this week. Until Monday, don't forget, Monday is my regular Night Sky This Week show. So do tune in. I'd love to see you where I share what is coming up in the night sky wherever you are around the world. Thanks so much for watching. And until next time, clear skies. Bye-bye.